One topic that we can guarantee you're going to be tested on is the stuff from this next chapter, which has to do with the time value of money. A lot of students find that they will need to go through the content from this chapter at least a few times, and they'll have to do a bunch of practice problems before they fully master it, but that's okay. And it's definitely worth taking the time to do that, again, because we can definitely promise you will see stuff from this chapter come up multiple times on your exam. The time value of money concept is based on the idea that money you have now will technically be worth more in the future. That's because if you have some money now, you can put it in the bank or invest it, and it'll have time to earn interest or grow in value. In general, the more time you have, the more your money will grow because it'll have more time to earn. If you have two lump sums being invested for the same rate, but one has a longer time period, the one with the longer time period will have a bigger future sum. When you're doing a word problem that's related to the time value of money, figuring out how much your money will be worth later is referred to as calculating its future value. The future value will always be more than the present value because there was time for the money to earn interest or earn a return. The concept also works in reverse, meaning that if you know you need a certain dollar amount at a certain point in the future, you don't actually have to set aside that much now because you can deposit or save a smaller amount and let it grow by earning interest until you hit that point in the future when you do need the money, by which time whatever you originally set aside would then be enough thanks to the interest earned. Figuring out what you need to deposit or invest now to eventually get to that future amount is referred to as calculating the present value. Now, every problem from this chapter is going to involve at least an interest rate and a number of time periods that the balance will be growing. Sometimes you'll be given those two bits of information in the word problem, and sometimes you'll be asked to work backwards to figure out one of those two because they're missing. Either way, it's important to understand how they fit into the time value of money concept. The rate used in a time value of money problem represents how much an initial lump sum is earning. The higher the rate is, the faster that balance will grow. If that lump sum is referring to money that you own and that you're investing, that's a great thing. But it can also be a bad thing if the lump sum is referring to a debt or loan balance that you owe. The second key component is the number of periods involved. This is basically asking you, how many times are you going to earn interest during the entire time period that you're looking at? So for example, if the problem says that you'll be earning interest compounded annually, meaning once a year for 12 years, then that means you're going to earn interest 12 times total. So you use 12 as your number of periods. Even if you know what rate is being earned and the number of time periods it's being earned over, one more thing you need to check to figure out how much your money will grow is to find out if the interest is being compounded or not. If your interest is not compounding, that is referred to as simple interest. Simple interest means the interest rate is only going to be applied to the principal, which is the original lump sum amount, and it's not going to earn any interest on the interest you've earned. To illustrate, let's say we had $100 that we deposited into an account that was earning 5% simple interest every year. Every year, we'd earn exactly $5 in interest because that's 5% of the original $100 principal amount. If we were dealing with compound interest instead, we'd get to earn 5% of the original principal plus 5% on any interest we've earned up to that point. So in year one, we'd earn the same $5 because that's 5% of 100, but then the second year, we'd actually be earning 5% of $105 rather than just the original $100 principal. 5% of the principal plus interest would come out to $5.25. If we keep going like this for years 3 and 4, our interest up to date at the end of year 4 would actually end up being $21.55 rather than just the $20 you would have gotten if your interest wasn't compounding. As you can see with compound interest, the amount of interest you are earning actually gets bigger and bigger with every period. Whereas with the simple interest example, the interest amount you earn every period stays exactly the same. Even though it doesn't look like that big a difference in our example, the compounding effect can actually be a huge game changer, especially if you're dealing with larger amounts or longer time periods or both. For example, if a 25-year-old put $5,000 in an IRA and just left it there, it could easily grow to well over $25,000 by the time they're 65 just because of the compounding thing. The compounding effect will always be more pronounced the bigger your initial lump sum, the higher your interest rate, or the more time you have for the compounding effect to happen. Another way for compound interest to work even more in your favor is if the interest is compounded more than once a year. To illustrate, let's say we put $100 into an account that earns 4%, but it's compounded quarterly rather than once a year. That means instead of earning 4% one time at the end of the year, the bank is going to spread out that interest rate between the 4 quarters of the year and pay you interest quarterly instead. In other words, they're going to pay you 1% 4 times during the year rather than 4% one time during the year. By the time you reach the end of the 4 quarters, you will have earned $4.06 in interest, whereas you would have only gotten $4 if you were earning 4% one time at the end of the year. The difference comes from the fact that you had a chance to earn interest on the interest you earned during the prior quarters. Remember how we said the longer a time period you had, the bigger your final balance will be because it will have compounded more often? Well, the same logic applies if your interest is compounding more frequently than just once a year. If you have two options that are identical in terms of the rate earned and the total number of years compounding, but one compounds more frequently during the year, like semi-annually or monthly, then that option will earn more than another option that compounds less frequently during the year. Now, the provided annual interest rate is always referred to as the stated interest rate, but whenever you compound the interest more than once a year, the actual interest you'll earn each year will always end up being higher than the stated rate because you got to earn a little extra from the interest you were accruing during the course of the year. The actual rate that ends up being earned is referred to as the effective annual interest rate. And again, the effective rate will always be higher than the stated interest rate. Always. Okay, so now it's time to actually get into how to calculate this stuff. It was worth taking the time to learn the theory because those could come up on your exam too, but you'll definitely need to calculate at least a number or two on your test. So let's show you how to do that. The first type of problem you might face is having to calculate simple interest. All you have to do is take the original principal amount, then you times it by the rate you're supposed to earn, and the number of years you'll be earning that. For example, if you have $100 that earns 5% annually for 5 years, that means you would take $100 times 5% per year times 5 years equals $25 of total interest earned. Piece of cake. Now, compound interest problems are a tad more involved, but still totally doable. These calculations basically involve taking the present value of a lump sum and multiplying it by a certain factor to get the future value of that same amount of money, or it might be vice versa, where you have the future value of a lump sum and you multiply it by a certain factor to figure out the present value. Now, the factor you'll use will differ depending on the interest rate and the number of periods or years that you are compounding. You can calculate that factor in one of 3 ways: by doing a manual calculation using a formula, by using a financial calculator, or by using the present value and future value tables that we have included as printables as part of this study program. No matter what, every compound interest problem will always be based on these 4 elements: the present value, the future value, the rate, and the number of periods. And as long as you have any 3 of these 4 pieces of information, you can always figure out the missing element, which is exactly what you'll be doing on the exam. Now, the Institute's CPCU 540 course shows you how to do these calculations using formulas But pretty much no one uses formulas nowadays, either in the real-world workplace or for the exam. Instead, most students will use present and future value tables or a financial calculator because they are much faster and easier. Our study program assumes you will do the same, and we include multiple sets of lessons for this chapter showing you how to apply either of those methods. It's important to understand that whether you're using the financial calculator or the provided tables, those tools will not tell you what those 4 pieces are. You need to learn how to identify the 3 of the 4 provided pieces before you can use that information to either enter into the calculator or look up on the table what the 4th and final missing piece is. In case you missed it, we do have a separate video in our intro module that talks about the pros and cons of using a financial calculator. Regardless, you should still watch all the videos in this chapter, even if you're using a calculator, because you still need to learn how to identify the 3 out of 4 provided elements. Now, before we get into the lessons on all the variations of time value of money problems that you may encounter, we do want to take a second to give you a little pep talk on using the tables. Some people hear the word calculator and automatically assume that it must be much easier. But some people find that's not necessarily true, and the tables aren't really that hard. People use tables all the time in everyday life because they're easy to understand. Take this example, which shows how many cookies my roommates and I ate during each day of the week. We could use this table in several different ways. If we wanted to know how many cookies a particular person ate during a certain day of the week, we can check where that person's name and the day of the week intersect to see what the table tells us. If we want to know who in the heck cleaned out all the cookies on Thursday and was rude enough not to buy a new box, we can just look in the Thursday row to see how many cookies each person ate. Now, if we suspect one person is hogging all the cookies, we can just check their column only to see what it tells us. And finally, if we know that somebody ate at least 30 cookies in one sitting, we can look for that result in the middle of the table itself, and then look in the appropriate column and row to find out when that happened and who was the culprit. The present value table and future value tables that you'll be provided work exactly the same way as any other table. The top shows the interest rate, and the side shows the number of periods that are being compounded. So if you know the number of periods and the rate being used, you just have to look where they intersect to find the appropriate factor. If you know the interest rate and the factor, then you can look down the appropriate column for that interest rate until you find the factor to get the number of periods. Likewise, if you know the number of periods and the factor, and you're just trying to figure out the interest rate, look in the appropriate row for that number of periods and see which column that factor appears in to get the appropriate rate to use. Again, this is no different than using any other table. Now, one thing we want to mention is that sometimes the answer choices on the exam won't exactly match what you came up with down to the penny because there's rounding involved. If you're going with the tables instead of the financial calculator, you should always use up to 4 decimal places for every number so that you can get a precise enough answer that you can figure out which answer choice is obviously the closest one. The tables get a bad rap, but honestly, they're not that hard to use as long as you practice. Our videos and printables give you plenty of opportunity to do that, and we'll walk you through every step of the way, so don't be afraid to use them.